Hello friends. In the last video, we looked at implementing a singly linked list. In this tutorial, we will look at implementing a new data structure called a doubly linked list. So in the screen on the left side, you can see the representation of a doubly linked list. So unlike a singly linked list where we had a connection like this, so we had a couple of nodes. So we had nodes and these nodes were connected with a next pointer. But there was no way to go back to the previous node. Let's say I was at this node and I wanted to get the value of the previous node. The only way to get the value of the previous node would have been to go through the list again. So in a doubly linked list, we have the convenience of going back to the previous node. So let us say I'm at node 2. This is node 2 and I want to get the value of node 1. So how can we do this? So in a doubly linked list, we have every node has a next pointer and a previous pointer. So we have a data structure like this. We have a next pointer and a previous pointer. And of course, there is also the head of the node. So we will look at implementing this data structure in Python and some common operations we can perform on a doubly linked list. Some common operations we can perform are insertion, traversal, and deletion. So we will look at insertion and deletion in this tutorial. So let us begin by implementing initially the node class. So the node class, so this is the constructor of the node class, and the node class has a data value, the pref pointer, and that is the previous pointer, and the next pointer. And initially when a new node is constructed, that is, let's say I'm creating a new node like this. So initially this node will have a value and this value is assigned to self.data, and the prev and none and the next would initially be none. Now let us see how we can implement a doubly linked list in Python. So I have defined a class called doubly linked list, and when I initialize an instance of this class, the head value is going to be none. So now we will look at some common operations we can perform on a doubly linked list. So the very first operation we will look at is what is called insert front. That is, we want to insert a new node at the front of the list. So let us see, I have this list like this, and they are connected with the next pointer as follows, and I want to insert a new node. I want this to be at the front of the list. So how can I do this? So this is the head. So to insert a node at the front of the list, all that I need to do is I need to point this node's next to point to the head. The head's pref should point to this node, and the head will be reinitialized to point to this newly created node. So let us see how we can implement this. So I have a function called insert front, and initially I will check if the list is empty or not, and I can check this by looking at the head value. So if the head value is none, that means the list is empty. And so if the list is empty and I want to put this node in the list, all that I need to do is point the head to this node. So that is what I'm doing in the else block. So I'm doing self.head is equal to node. But if the list is not empty, then I'm going to perform this operation which I've explained. So what I will do is I will point the node's next to point to head. So node.next is equal to self.head, and the head's previous pointer is going to point to this node. So self.head.prev is equal to node, and then I will reinitialize the head pointer. So self.head is equal to node. Now we will look at implementing a functionality to insert a node at the end or at the tail of the list. So let us say I have a list like this. So, and they are connected with the next and pref pointer. And now let's say I want to have a node at the end of the list. So what I'm going to do is I'm going to point the last node's next to point to this newly created node, and this newly created node's pref pointer will point to the last node. And of course this is going to be the newly created node's next pointer is going to be null or none. So let us see how we can do this in Python. So I have a function called insert back. Again, I will check if the list is empty or not. If the list is empty, then I just assign the head pointer to point to this node. But if the list is not empty, then I will initialize a variable called current node, which is initially pointing at self.head. So I'm initially out here, and now I have to traverse the list till I reach the last node. So this would be my last node. So I've used a while loop to traverse through the list. Once I'm at the last node, that is, I will check if the last node's next is none or not. If the last node's next value is none, that means that we have reached the tail of the list. Then I come out of the while loop, and what I do is now when I come out of the while loop, this is the current node. So what I'm going to do is current node's next, that is current node.next, will point to this node represented by node, and node's prev will point to current node. So node.prev is equal to current node. This is all that we need to do to insert a node at the end of the list. Now we will look at another functionality to insert a node at some position in the list. So let us say I want to insert a node at position 3. This is position 1. This is 2. Initially this is 3, and this is 4 now. Now I want to insert a node at position 3. So this will become 4 and this will become 5. So what do I have to do? I have to point the second node's next to point to this node. This node's prev will point to second, and this node's next will point to this one, and this node's prev will point to this. This is the connection that I need to do. So how can we achieve this? So let us see. So I've set a counter. So this function will take the node that we want to insert and the position where we want to insert this node in the list. Then I am setting a counter. So current counter is 1 and the current node is head. Now I have to traverse the list till I reach that position where I want to insert the node. So while current node is not null, if current counter is index -1. So let us say I reach this position. Then I'm going to do nodes next. So this nodes next is going to point to current nodes next. So current nodes next is pointing to, so these two values should be same. So node.next is current nodes next, and nodes prev will point to current node. So node.prev is equal to current node. Also current nodes next will point to this node. So current node.next will point to node. And I also need to make sure that, let us say I want to insert a node, but this node is not being inserted at the last position. So I also need to make the next value of this node the next node's previous pointer. So this connection, I also need to make this connection. So I check if node.next is not null. Then I will do node.next.prev will point to this node. This is the connection that I am doing on this line. So if node.next is not null, node.next.prev is equal to node, and then I return from there. So this is how we can insert a node at any position in the list. Now we will look at another important function, that is deletion. So let us say I have a list like this. I have a list, I have some nodes, they are all connected, right? We have a list with this connection. This is 1, 2 and 3, and I want to delete node 2. So how can we do this? So what I need to do is I need to connect second node's prev to point to second node's next. So I need to make this connection. I also need to connect second node's next prev, so that is, this should point to second node's prev pointer. So let us see how we can do this. So I have so first, of course, I need to check if the list is empty or not. Now if the list is not empty and we are not so we are trying to delete the second node, so I'm going to initialize a variable called temp node, which will point to self.head.next. So then what I need to do is, so I'm at this position initially. Then what I need to do, I need to first ensure that is this the node that I want to delete, because in this function we are also passing in the value of the node that we want to delete. So we check if temp node.data is equal to the value that we want to delete. If it is so, we will enter the if block. And now we will do temp nodes prevs next. So temp nodes prev is this node, and this node's next will point to temp nodes next. So temp node dot prev dot next would be temp node dot next. Also temp nodes next, that means this node, and this node's prev should point to temp nodes prev. So temp node dot next dot prev is equal to temp node dot prev, and then I can just point this to none and delete it, and then I can return from this function. So this is how we can delete a node in the list. And we also have a display function, which is exactly the same as in the previous tutorial, to print the list in the forward order and in the reverse order. So I have two print statements in this case. I have a list to go through the list in this order, and also to go through the list in this order. So let us experiment and see if our functions work and the results that we get. So I'm going to comment out some lines initially to make you understand the logic. Okay, so initially I have two nodes. I have a node with value 12 and I have a node with value 13, and I'm going to create an instance of this class, and I will insert these two nodes at the front of the list, and I'm going to display this function. So let us see what we get. So we have once I inserted the 13th node with value 13, this would be at the front of the list. So this is what we are getting. We have 13 and then we have 12, and if we print the list in the reverse order, we would have 12 and then 13. Now we will try to insert a node at the end of the list. That is, I'm going to call this function insert underscore back, and I'm going to insert two more nodes, 14, 26. So the result should be 13, 12, 14 and 26. And I will also insert one more node at the front of the list. So the front of the list will have a node with a value of 1. So let us see the result that we obtain. So we see we get 1, then 13, 12, then we have 14 and then 26. And in the reverse order, we would get 26, 14, 12, 13 and 1. Now we will try to insert a node at some position in the list. So I'm creating two more nodes, node 2 and node 5. Node 2 should be at the position 2, and node 5 should be at the position 3. So let us see the result that we obtain. So as you see, we have initially it was like this: 1, 13, 12, 14, 16, and in the second position I have inserted a node with value 2, and in the third position I have inserted a node with a value 5. So we get 1, 2, 5, 13, 12, 14, 26, and in the reverse order we would get 26, 14, 12, 13, 5, 2, 1. Now we will look at the last operation we can perform on this list. That is, we will try to delete a node. So I want to delete the node with value 5. So I want this node to go away. So what will happen once I call this function? I would have 1, 2, and 2 would be connected to 13, and then 12, 14, 26. So let us see if this works. So this is the result that we have obtained. We were at this, we had a list like this: 1, 2, 5, 13, 12, 14, 26, and then I deleted 5, and then I got 1, 2, 13, 12, 14, 26, and in the reverse order 26, 14, 12, 13, 2, 1. So this was all about a doubly linked list. As you can see, in a doubly linked list we have the convenience to go back to the previous node, which was not possible in a singly linked list. In the next tutorials we will look at some questions, some problems we can perform using a doubly linked list. I hope you liked this tutorial. Thank you.